In this video, we're going to look at an example of Java's use of an interface, and that's the comparable interface. So the comparable interface is provided by Java. It's defined in the java.lang package, okay? And it looks like this. Public interface comparable, and you have to specify a type for that. It's a generic, okay? And it has one method that is required, and that is a method called compare to, which we have used in the past. We use compare to compare strings. So the string class must implement the interface comparable. Okay, so it's in Java. We're going to see some examples of it. So anything that implements comparable must have a compare to method. And by doing that, we create some functionality that we can make great use of. So let's look. We got the integer and big integer classes. Both of those, integer extends number, big integer extends number, and they both implement the comparable interface, meaning they both have a compare to method built into them. Integer.compare to. We have an integer compare to, and we have a big integer compare to. The string classes also implement comparable. And so strings have a compare to method built into them, which we have used. The date class has a comparable methods that will compare dates. Now, the implementations of these all work differently. I compare two integers by actually looking to see if one's bigger than the other. I can compare two strings to look to see if lexicographically some of their characters come before other characters. And I can compare some dates by looking at the year code or the month code or a combination of the year, month, and day codes. Each of them implemented differently, but they all have the method built into it, which means they can all be compared to another object of their same class. So I can compare an integer to another integer. I can compare a big int to another int. I can compare two strings. I can compare two dates because they all have the compare to method because they implement the comparable interface. So here's some examples. I can print out a new integer with the number 3. Notice I'm using capital I integer here and calling it compare to a new integer number 5. Remember, if compare to returns a -1, 0 if they're equal, or 1 if they're larger. So I can compare two strings using ABC compared to ABE. I can compare two dates. So we created two new date objects here, and then we can compare them together. Okay. And remember, println is going to print either the 1, the 0, or the -1. But because they all have comparable, they can also be used in the sort method. Remember generic? We had generic sort. Let n be an integer object, s be a string object, and b be a date object. The following expressions are true. N, because it's an integer, it's an instance of integer. It's also an instance of object. It's also an instance of comparable because the integer class implements the comparable interface. Okay, the same is true of string. It's an instance of string, object, and comparable. And date is an instance of date. It's an instance of object because everything in Java is. All of them are instances of comparable. So let's take a look at some examples of sorting comparable objects. Here, we're creating an array of strings: Savannah, Boston, Atlanta, Tampa. These are cities. And we can call arrays.sort. Arrays.sort works for any class that implements comparable. So any class that has the compare to can be sorted using Java arrays.sort. So it works just fine. We can also do that with big ints. We can call arrays.sort on a bunch of ints because sort relies on that comparable interface. we can also create our own implementations of that interface comparable. So we have a geometric object. We made a rectangle class, if you remember this example that we did previously. We can create another class of rectangle called a comparable rectangle. And comparable rectangle is going to implement the comparable interface. That means it's going to have a compare to method. And because it has a compare to method, we will be able to sort our rectangles. So let's look at some example code of this. So here is our comparable rectangle class that extends rectangle, but it also implements the comparable rectangle. It implements comparable on itself. So here's the class constructor. And then here is its compare to method. It had to have the compare to method because it was implementing comparable. Okay. And how we choose to implement that is up to us. Maybe we want to return the widest rectangle. Maybe we want to compare the two rectangle heights. But in this case, they're comparing the two rectangle areas. If the area of this object compared to the other object that is passed in, which gets a variable of O, if this area is bigger than that, we're going to return a 1. If our area is less than the other object's area, we're going to return a -1. And if they're the same area, we're going to return a 0. So because this comparable rectangle class has implemented compare to, we can now use it to sort a bunch of rectangles. And here's an example. We create a bunch of rectangles right here. They created 4 of them. And we can call, and they're all inside this array called rectangles. Okay. And now, because they all implement comparable, we can call arrays.sort and sort the rectangles and then print them out, and they'll work just fine. Okay. So by implementing some of the interfaces that are built into Java, like comparable, we have utilities like sorting that will be available to us because our classes implement those interfaces. We can use the ones that are built in, like the integer compare to or the string compare to, but we can also write our own, like we did here for comparable rectangle.